At dawn, San Francisco occasionally misplaces a bridge. Fog rolls through the strait, the towers fade, and one of the world's most recognizable structures becomes an extremely expensive rumor. That was roughly the environment engineers chose for hanging a road between San Francisco and Marin County. The mile-wide strait had deep water, powerful currents, strong winds, and fog that could hide a ship until it had joined the meeting. Before the bridge, ferries carried people across. A fixed crossing sounded convenient. It also sounded impossible, dangerous, and ruinously expensive. So naturally, San Francisco formed a committee. After opposition, permits, redesigns, and financing battles, construction began in January 1933 during the Great Depression. The main span would stretch 4,200 feet between two towers. At the time, no suspension bridge had crossed farther between supports. First came the foundations and anchorages. The South Tower site sat in open water, so crews built a long temporary access trestle. Fog helped a ship crash through roughly 400 feet of it. The crews repaired the trestle. Then a gale smashed about 800 feet of it. The Pacific had reviewed the proposal and requested larger margins. The towers rose 746 feet above the water, carrying enormous compression forces into their foundations. But towers alone do not make a suspension bridge. They make two very ambitious landmarks with no useful relationship. The relationship arrived one pencil-thick wire at a time. A spinning shuttle carried wire from one anchorage over both towers to the opposite shore and back. Again, and again, and 27,572 times for each main cable. Packed together, those wires formed two cables more than 3 feet thick. Across both cables, the wire would stretch about 80,000 miles if placed end to end. The bridge was not given cables. It was given a small metallic planet. Vertical suspender ropes then dropped from the main cables. Workers added roadway sections from both sides so the structure settled instead of performing an unscheduled cartwheel. Below them, Chief Engineer Joseph Strauss required safety lines, protective equipment, and a large net. The net saved 19 workers. 11 workers still died, including 10 when a scaffold fell through the net. Their names are commemorated at the bridge. The danger was real. So was the effort to change what bridge work considered acceptable. By November 1936, roadway sections advancing from opposite shores finally met at the center. Now the load had a continuous path. Deck to suspenders, suspenders to main cables, cables over the towers, and cables into giant anchorages. Gravity pulled down. The cables pulled toward the shores. The towers pushed into the foundations. The bridge stayed up because every part was being bullied in a different, carefully calculated direction. Then came the color. The steel arrived in reddish primer. Architect Irving Morrow saw how it worked against hills, ocean, sky, and fog. Instead of standard gray or black, he developed the deeper red-orange, now called Golden Gate Bridge International Orange. It belongs to the landscape and refuses to disappear inside it. Architectural diplomacy conducted at maximum saturation. After 1,604 days of construction, it opened to pedestrians in May 1937 and vehicles the next day. Its 200-foot main span held the world record until 1964. But the more interesting achievement is not the old record. It is that the bridge remains flexible. Wind, temperature, traffic, and earthquakes can make it move. Movement is not failure. Movement is how a suspension bridge avoids becoming a very long cracker. So how did engineers hang a road over hostile water? They did not defeat gravity, wind, fog, or the Pacific. They gave each force somewhere useful to go. The Golden Gate Bridge looks effortless because the struggle is distributed through every cable, tower, anchorage, and moving joint. And when the fog hides it again, the bridge has not vanished. It is simply letting International Orange handle customer support.